For our first quiz. No, our second quiz, I suppose. For, what is this, Math 243. Given a bunch of data, not told a story about it because I wasn't feeling too clever, and asked to create a stem and leaf plot. Okay, basic idea with the stem and leaf plot is you want to summarize 2-digit data by kind of keeping track of the last digit as the leaf and all other digits as the stem. That's one way you can say it. So what I'm saying is 6 you can think of as 0, 6. But 15 would be 1 and then a 5. 21 would be a 2 and then a 1. 25 would be a 2 and then a 5. 27 would be a 2 and then a 7. I have another 27 and a 29. Then I got a 30, a 31, another 31, 32, 33, 35, and a 38. And then I got 44 and 49. And I got 50 and I got a 60. So right here is a stem and leaf plot. What is important? First of all, that your stems are decreasing. I don't know, I guess that's it. And then it looks like this. Fine, here's your stem and leaf plot. Good enough? Good enough. Moving on. Sketch a histogram of the data starting at 0 with a bin size of 7. You can do that by hand, but since I have this fancy calculator over here, I'm going to use it. So the way I'm going to use it, I'm going to hit this stat button here, and then under edit, I'm going to enter as my first list all of these data points. And the way you do it is just like you'd think. You type in 6 for your first observation, hit enter. My second observation is 15. Type in 15, hit enter. 21, hit enter. And keep doing that for all of these data points. I'll put the video on pause when I do that so you don't have to watch. Entered all my data. Note it's asking for the 19th data point, so presumably that means I have 18 up here. 2, 4, 6, 8, 10, 12, 14, 16, 18. Good. Means I got them all in. Sketch a histogram. The way you're going to sketch a histogram is A, put your data in. Remember what list it's in. Mine's in L1. Then go into stat plots. So second and then y equals to get to stat plots. And go into one of your stat plots. Turn it on. And then select the histogram icon. If you want to go through this slower, I have a video on how to make these things on my website. Then you tell it what list your data's in. Mine's in L1. It defaults to L1. That's convenient. Frequency down here is just a default. Leave it as 1. Then hit window. Why do you hit window? Because you want to specify the size of your bins. You want to tell it that you're starting at 0. That means your X minimum should be 0. Your X maximum, well, let's see. I'm starting by 7s. I want to make sure that I get 60 in there. So I guess my last bin will go up to 63. Just some number bigger than 60 here, and you'll be able to see everything. Your X scale, that's your bin size. It's important to make that 7. Y minimum, I don't know, 0 is fine, -1 is fine. This is just talking about the most observations in any of my bins. I put -1 so I have a little border. The least is 0 and the most. What's the most that I'd have in any bin? I don't know, I can't tell. Say 6 or 7 or 8 or so. Just pick more than you would have in any bin so that the whole thing shows up. Get all that information in there, hit graph. There's your histogram. Cool. Copy that thing down over here. Because we're going up by 7s, this is 7, 14, 21, 28, 35. I have to go big enough so that I can hold a 60. So we'll be here for a while. 42, 49, 56, and 63. If you had trouble coming up with those numbers, what you can do is you can hit the trace key over here, and it tells you your first bin goes from 0 to 7, and you have 1 of them. So fine, here is 1. My second bin goes from 7 to 14. I have none of them. And then from 14 to 21, it looks like I have 1. 21 to 28, I have 4. 1, 2, 3, 4. Something like that. 28 to 35, I got 6 of them. So let's see, here's 6 way up here. Uh, 35 to 42, I have 2 of them. 42 to 49, I got 1. 49 to 56, I got 2. And then finally, 56 to 63, I got 1. Sketch a histogram of the data, starting at 0 with the bin size of 7. There you go. Using your answers to 1 and 2, comment on the shape of this data. All right, it's a little bit ugly, let's be honest. What I was hoping you would see is this is approximately normal. Looks like most of the data is in the middle, and it stretches out to either side, above and below. Most of it's in the middle, and it stretches out to either side, above and below. What I would say is that it's close enough to this certain type that we have 3 names for. Approximately normal, aka bell-shaped, aka symmetric. Other answers are okay. If you thought this was left skewed, I guess, if you kind of ignore this one, most of the stuff, well, no, I guess you'd call it right skewed. If you kind of ignore this, most of the stuff's on the left and you have this tail to the right. I might even say that other answers may be okay if justified. If you make a strong argument for something and really show that you understand what we mean by different shapes, it's fine. Good enough. Calculate the mean and the median of this data and decide which of these measures is the most appropriate to use in this example. Okay, because I said shape was approximately normal, aka symmetric, aka bell-shaped, I'm going to use the mean. I'll report all of them, but it's mean that makes the most sense when things are approximately normal. How do you come up with those? Go over here to stat, go to calculate, and then one variable statistics. It says, all right, I can do one variable statistics. What data do you want me to do it on? Well, I want you to do it on L1 because that's where I put all this information in there. So I'll type in L1 and hit enter. FYI, if you leave off L1 here, if you don't tell it a list, it assumes you're talking about L1. So I didn't even need to put that in there. Hit enter, it gives me a bunch of stuff. Some of this is relevant to this question. The first one, X bar, is my mean. Looks like it's 32.39 maybe. Maybe I'll say approximately 32.39. What about my median? Turns out this tells you your median also. There it is, 31. Note that those two values are pretty close, 32 and 31, which is what you would expect when your data was approximately normal. Median and mean, I guess that's it. What about the next one? Calculate the range, the variance, and the standard deviation. All right, range is the easiest, but if you know the formula. All the range is your largest value minus your smallest value. You could just go back to the data and be like, well, my largest was 60 and my smallest was 6. So the range is 60 minus 6, which is 54. Or you can find those on there. Like my maximum value was 60. My minimum value was 6. So 60 minus 6 is equal to 54. That's your range. That's it. What about the standard deviation? Well, your calculator gives you that one too. So actually it asks for the variance second. Variance. In case you're curious, we're going to use the symbol S squared for the variance. Your calculator does not tell you the variance, at least not directly. It does tell you the standard deviation. For the standard deviation, we use the symbol S. Your calculator gives it to you here. The S, the standard deviation for this variable x, is 12.797. Maybe I'll say it's approximately 12.8. Something like that. So why did I just skip over variance? Well, because variance, I know S, variance is S squared. In other words, my variance is just 12.8 or 12.797696889. I don't care that you put in all those decimal places. I'm just trying to be precise. It's this thing S squared. If you square it, you get approximately 163, maybe 0.8. Something like that. I didn't tell you to round to one decimal place, so if your answers aren't exactly these, but they're close, good enough, I don't care. Range, variance, standard deviation. I don't really care that you know the symbols for these things. It's good to know them eventually. I don't really care for this quiz, I guess is what I'm saying. So if you said S squared, cool. If you said S, awesome. Like you know the symbols. If you don't, that's all right. Figure them out eventually. Range, variance, and standard deviation of the data, done. Fill in the blank. Using your answers to 4 and 5 and the empirical rule. Okay, empirical rule tells me that 68% of the data falls within 1 standard deviation of the mean, and 95% of the data falls within 2 standard deviations of the mean, and 99.7, damn near all of it, percent of the data falls within 3 standard deviations of the mean. This is what the empirical rule tells us. So how's that answer the question? Using your answers and the empirical rule, I can conclude that about 95% of the data, okay, we're talking about this second line here, would fall between what 2 values? Well, let's see. I got a mean of, in part 4, I figured out 32 point maybe 4. I'm going to round everything to 1 decimal place. And a standard deviation of 12.8. So what the empirical rule tells me is that 95% of the data will be somewhere from 2 of these 12.8s less than 32.4 to 2 of these 12.8s above 32.4. What I'm trying to say is 32.4 minus 12.8 times 2 of these 12.8s gives me 6.8. That's the lower bound here, 6.8. And doing that exact same thing, 32.4, but now I want to add 2 of these standard deviations, will give me 58. So the empirical rule, which tells me that 95% of the data falls within 2 standard deviations of the mean, in the context of this problem, which tells me that 95% of the data would fall between 6.8 and 58. Maybe I'll even highlight where I got these from. This one was 32.4 minus 2 of these standard deviations. And then this one was 32.4 plus 2 of these standard deviations. I don't know, I think that's kind of hard, but that's the end of the quiz. So we got some empirical rule, we did all sorts of one variable statistics, and we even drew some pictures on this one. So we went through all sorts of stuff on this quiz, but I'll end the video here.